Hello students, now we are going to start third part of chapter 1. In the last lecture, we were dealing with laws of chemical combination. So start with fifth part, Avogadro's law. Avogadro's law, it states that equal volume of gases at the same temperature and pressure should contain equal number of molecules. For example, if we consider reaction of hydrogen and oxygen to produce water, we see that two volumes of hydrogen combine with one volume of oxygen to give two volumes of water without leaving any unreacted oxygen. Means one volume hydrogen plus one volume of hydrogen plus one volume of oxygen. It gives two volumes of water vapors. Dalton's atomic theory. In 1808, Dalton published a new system of chemical philosophy in which he proposed the following. Number 1. Matter consists of indivisible atoms. All the atoms of a given element have identical properties, including identical mass. Atoms of different elements differ in mass. Compounds are formed when atoms of different elements combined in a fixed ratio. Chemical reactions involve reorganization of atoms. These are neither created nor destroyed in a chemical reaction. What is atomic mass? The atomic mass of an element is the number of times an atom of that element is heavier than an atom of carbon taken as 12. It may be noted that atomic masses as obtained above and are the relative atomic masses and not the actual masses of the atoms. One atomic mass unit, that is AMU, is equal to 1/12 of the mass of an atom of carbon 12 isotope. It is also known as unified mass, that is U. Average atomic mass. Most of the elements exist as isotopes, which are different atoms of same element with different mass numbers and the same atomic number. Therefore, the atomic mass of an element must be its average atomic mass, and it may be defined as the average relative mass of an atom of an element as compared to the mass of carbon atom carbon 12 taken as 12U. Molecular mass. Molecular mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by number of its atoms and adding them together. For example, molecular mass of methane CH4 12.011 U plus 4 multiply 1.008 U. It comes out 16.043 U. Formula mass. Ionic compounds such as NaCl, KNO3, Na2CO3 etc. do not consist of molecules, that is single entities, but exist as ions closely packed together in a three-dimensional space, as it is shown on the screen. Mole concept. It is found that 1 gram atom of an element contains the same number of atoms and 1 gram molecule of any substance contains the same number of molecules, and this number has been experimentally determined and found to be equal to 6.022137 into 10 raised to power 23. The value is generally called Avogadro's number or Avogadro's constant. It is usually represented by Na and its value is 6.022 into 10 raised to power 23. Percentage composition. One can check the purity of a given sample by analyzing the data. Let us understand it by taking example of water. Since water contains hydrogen and oxygen, the percentage composition of both these elements can be calculated as mass percent of an element is mass of that element in the compound multiply 100 divided by molar mass of compound, and on the screen taking example of H2O and find out mass percentage of hydrogen, mass percentage of oxygen. Empirical formula. The formula of the compound which gives the simplest whole number ratio of atoms of various elements present in one molecule of the compound. For example, the formula of hydrogen peroxide is H2O2. In order to express its empirical formula, we have to take out a common factor 2. The simplest whole number ratio of the atom is 1:1 and the empirical formula is HO. Similarly, the formula of glucose is C6H12O6. In order to get the simplest whole number of the atoms, the common factor is 6. So ratio is 1:2:1. The empirical formula of glucose is CH2O. Now, molecular formula. The formula of a compound which gives the actual ratio of the atoms of various elements present in one molecule of the compound. For example, molecular formula of hydrogen peroxide is H2O2 and glucose is C6H12O6. So, molecular formula is equal to N into empirical formula, where N is common factor, also called as multiplying factor. The value of N is 1, 2, 3, 4, 5, 6, etc. In case N is 1, molecular formula of a compound is empirical formula of the compound. Now, stoichiometry and stoichiometric calculations. The word stoichiometry is derived from two Greek words, stoichion and metron. Stoichiometry thus deals with the calculation of masses of the reactants and the products involved in a chemical reaction. Let us consider the combustion of methane. A balanced equation for this reaction is as given below. This CH4 when react with O2, it gives CO2 and water. Upon balancing, it gives CH4 plus 2O2, it gives CO2 plus 2 water. So, balanced chemical equation tells about stoichiometry. Limiting reagent. Sometimes in a chemical equation, the reactants present are not the amount as required according to balanced equation. The amount of products formed then depend upon the reactant which has reacted completely. This reactant which reacts completely in the reaction is called the limiting reactant. The reactant which is not consumed completely in the reaction is called excess reactant. Now, there are four ways of expression of concentration of the substance. Number 1, mass percentage. You have done it already. Mole fraction, molarity and molality. So, start with what is mole fraction? Mole fraction is the ratio of number of moles of a particular component to the total number of moles of the solution. It means X2 is equal to N2 upon N1 plus N2, where X2 means mole fraction of solute, N2 is number of mole of solute and N1 number of moles of solvent. And it's an identity that X1 plus X2 is equal to 1. What is molarity? It is defined as number of moles of solute in 1 liter of solution. Molality? It is defined as number of moles of solute present in 1 kilogram of solvent.